Good evening, one and all. आज पुणी मु आपण सहित आछि आउटे नुआ चैप्टर ने की. So I will write some formula here regarding integration and I will prove it. So let's see. First formula that I am going to prove you here, that dx by 1 minus x square root over is equal to sine inverse x plus c or minus cos inverse x plus c. We know this formula, right? But what we are going to prove in CHSE, this chapter in the exercise of 9D, and the formula is dx by a square minus x square root over integration is equal to sine inverse x by a plus c. This is the first formula and I am here to prove it. See, first formula, I am writing the question again, that is given that dx by a square minus x square root over integration. So I am taking, let us consider x is equal to a sin theta. Okay, then definitely as x is equal to a sin theta implies I can write dx by d theta is equal to a into cos theta. Okay, so I can write dx is equal to a cos theta into d theta. Okay, so now my question will become dx by d, in the place of dx I can write a cos theta into d theta. Okay, divided by root over of a square minus, as I have taken x is equal to a sin theta, in the place of x square I can put a sin theta whole square integration. So now it will become a cos theta divided by, from this 2 1 I can write this one as a square minus, as a sin theta whole square I can write it a square sin square theta root over d theta integration. Okay, so here a cos theta divided by, from these two I can take a square as common and I will get 1 minus sin square theta root over d theta. Okay, so now what it will become, that a cos theta divided by a square root over will be a, and as we know that 1 minus sin square theta is cos square theta, the root over of cos square theta will be cos theta d theta integration. Here a and cos theta will cancel out each other. Right now in the question we have d theta integration. As we know that d theta integration is theta plus c. Now what is the value of theta we have to find out. See, I have taken x is equal to a sin theta, implies sin theta is equal to x by a. Okay, then theta is how much? Theta will be sin inverse x by a. So in the place of theta I can put sin inverse x by a plus c. The formula that is written dx by root over of a square minus x square integration is equal to sin inverse x by a plus c is right now proved. The next theorem is that integration dx by a square plus x square, I am taking at theorem 2, is equal to 1 by a tan inverse x by a plus c. So I am here to prove this question, that 1 by a tan inverse x by a plus c So just remember three formula that I am writing here. In any question, if there are term a square minus x square, if any question there is a term a square minus x square, they blindly put x is equal to a sin theta or a cos theta. If any question a square plus x square is given and you are unable to solve it the question by any method, then blindly put x is equal to a tan theta else a cot theta. If any term that contains x square minus s square and you are unable to put any formula here, then put x is equal to a sec theta, otherwise what? A cosec theta. So now, as here a square plus x square term is here, so I can put x is equal to a tan theta here. Okay. So the integration of derivative of x, that is dx by d theta, is equal to a is a constant, and we know the derivative of tan theta will be how much? Sec square theta. If dx by d theta is equal to a sec square theta, I can write dx is equal to a sec square theta d theta. Okay, d theta. Okay, I am proving it this side. See, so we have got the dx is equal to a sec square theta d theta. So in the question part, we have dx divided by a square plus x square. So instead of writing dx, right now I can write a sec square theta d theta divided by, in the place of a square I am putting a square, and the place of x square I am putting a square tan square theta, because I have taken x is equal to a tan theta. So in the place of x square I am putting a tan theta whole square, that means a square tan square theta. So now our question had become a sec square theta d theta divided by a square plus a square tan square theta. So have a look, a sec square theta d theta divided by, from these both terms I can take a square as common, and I will get a term that is 1 plus tan square theta. Okay, we know that 1 plus tan square theta is how much? Sec square theta. Then it will be a sec square theta divided by a square sec square theta d theta. Okay, here a and 1a are getting cancelled. Sec square theta and sec square theta are getting cancelled. Here in the denominator part we have 1a. I can take 1 by a to the outside part. So right now in the question I have only d theta integration, and we know the integration of d theta will be theta plus c. Have a look here. We have x is equal to a tan theta. If x is equal to a tan theta, I can take x by a will be is equal to tan theta, right? If x by a equal to tan theta, then theta is how much? Tan inverse x by a. So here instead of writing theta, I can write 1 by a tan inverse x by a plus c. Okay, so both the theorem, that is dx divided by root over of a square minus x square is equal to sin inverse x by a plus c, and the second formula, that is dx by a square plus x square is equal to 1 by a tan inverse x by a plus c, are proved. I think you have understood both the theorem. So thank you. For this type of more video, please like, share my videos. Thank you.